Alright, we haven't seen one like this yet. In number 9, we have an x cubed term. So the highest power of x is 3 this time. This is called a cubic equation. And the highest power of x is 3. Let's go ahead and plug in x values and see what we get. If I cube negative 2, then that means take negative 2 times negative 2 times negative 2. Negative 2 squared is positive 4. Positive 4 times negative 2 is negative 8. So I'll just write that down up here. I'll just do this one. I won't write down the others. Negative 1 times itself 3 times gives you a negative 1. 0 times itself 3 times is 0. We get 1, and then positive 8. So now let's graph this. Y values go up to 8 and down to negative 8. X values 1, 2, negative 1, negative 2. And I want to say where y equals negative 1 and 1 are fairly accurately. So I'm going to say halfway between 0 and 8 is 4. Halfway again is 2. And halfway again is 1. So my y values are scaled a little differently than my x values, and I'm okay with that. Got a point at negative 2, negative 8. Negative 1, negative 1. Looks like it's about right here on my graph. 0, 0, 1, 1, and then 2, 8. So if my y values were scaled like my x's, these y values would be stretched out a little bit. So the picture that I'm drawing is a little, it's basically a compressed version, vertically compressed version of the graph. Now we connect these with the smooth curve, and that would look something like this. All right, so this is what a cubic equation generally looks like. If you add more terms after this, like an x squared term and an x and a constant, what it can do is it can give you a couple of waves down here in the middle part, but the basic shape will still be the same. It would come up if the coefficient of x cubed is positive, then from the left it's going to come up, and then it could go up and down and then back up. For the shape of this graph, you could just call this shape cubic, or another way to say this is that it looks like a parabola. Let me draw what this would look like if it was a parabola, something like that. It looks like a parabola where you've taken the left arm and twisted it down. So let's also call this a twisted parabola. All right, and then the y-intercept is where you hit the y-axis. That's at the origin for this one. All right, now number 3, this looks different than what we've seen before. Whether the y values increase or decrease as x approaches infinity. So we're going to pay attention to what the y values do as x approaches infinity. X approaches infinity means you're going out this way. These are the x values, and infinity is out to the right. So as x goes out to the right, the y values are going up. So I would say the y values increase as x approaches infinity. And then 4, whether the y values increase or decrease as x approaches negative infinity. X approaching negative infinity means you're going from right out to the left on the graph. And as you go from right to left, the y values are going down. So I would say the y values decrease as x approaches negative infinity.